We're on the 14th lesson of Precalculus using a textbook by Larson. This is Chapter 2, Section 6, Rational Functions and Asymptotes. All right, so the best way to understand what an asymptote is to look at a picture of one. So going down here on the bottom of the page, we have on this one, this is the graph of 2x plus 3 over, no, it's the graph of 2x plus 1 over x plus 1. It's hard to read it. 2x plus 1 over x plus 1 is what this graph is. It has got a vertical asymptote at x equal to negative 1. And it's got a horizontal asymptote going left and right at y equal to 2. So the graph is getting closer and closer to this horizontal asymptote of 2, but it's never going to cross the line of 2 on the left or the right. It just gets really close to it. And then as it goes up and down, it gets close to that line of x equals negative 1, but it's never going to cross it. It just gets infinitely closer and closer to it as it goes to infinity. So that's what the definition is up here of it. It talks about infinity. A line x equals a is a vertical asymptote of the graph of f when f of x or y approaches infinity, positive or negative. And down here, that's what's happening for the vertical asymptote. It's approaching from the left, it's approaching positive infinity, and coming in from the right, it's going down the negative infinity. And then a horizontal asymptote, the line y equals b is a horizontal asymptote of the graph of f when f of x or y approaches some value b. And our value of b down here, and the one we just looked at, it was approaching the number 2. So as x approaches infinity, or as x approaches negative infinity, it approaches that value b. So as the x approached infinity from the right here, as it goes to positive infinity, it's approaching positive 2. And from the left, it's also approaching positive 2 as it gets infinite from the left and the right. Here's another one in the middle that was fun. I like this one. It is the graph of 4 over x squared plus 1. So it has got a horizontal asymptote here at y equals 0. So it's getting closer and closer to 0, but it never crosses it. Kind of fun. And then this one is the equation 2 over x minus 1 squared. It has got a vertical asymptote at x equals 1 and a horizontal asymptote down here at y equals 0. And it's getting closer and closer to it as x goes to infinity from the left and the right. It's going to approaching y equals 0. All right, so let's do some of these on the next page. Oh, they summarize it here on the next page, all the rules for us of how you find them. So the get a vertical asymptote is the zeros of the denominator. It's all about the zeros of the denominator. So you set the denominator equal to 0 and you solve it. The horizontal asymptote is a little bit more complicated. So this is the polynomial up here on the top. X to the n is on the top. That's the highest term on the top. And on the bottom, they have an m. It's x to the m. So it says when n is less than m, let me go back up here. When n is less than m, so when the one is smaller than the other one, so like if you had, we'll go to suppose land, if we had x to the third over x to the fifth, so n is less than m. When that happens, when n is less than m, you get the number 0 because it goes to infinity. You can reduce it. When you reduce it or cancel it out, it makes 1 over x squared. So as the graph goes infinity, it becomes 1 over infinity, which is 0. So that's why it makes the line y equals 0. So I like to call it bottom heavy. When it's bottom heavy with the x's, So when there's more x's on the bottom than on the top, when it's bottom heavy, it makes the line y equals 0. If n equals m, on the next one here it says if n equals m, so like maybe you have 3x to the third over 2x to the third, so the powers, when they're equal, the x's cancel out and you get the coefficients of what's there. So you get a line like 3 over 2. Back here on the first one, that's how we got this one here, that y was equal to 2, because the coefficients of the x's of highest degree, 2x and 1x, the x's cancel out, it just becomes 2. And so on the last one here, when n is less than m, like let's just suppose maybe x to the 5th over x to the 3rd, then you have no horizontal asymptote at all. There isn't one at all, because things cancel out and you've got x squared. So as it approaches infinity, it just keeps going to infinity, and it's not approaching an actual number at all, it's just becoming infinite. All right, so we're going to find vertical and horizontal asymptotes. The first one is 3 over x minus 2 to the 3rd. So just starting with the vertical asymptotes on it, that we said is when the denominator is equal to 0, and the denominator here is x minus 2 to the 3rd. So I'll just set the whole thing equal to 0. I know the bottom line is it's what's inside the parentheses, but I'll just do the whole thing. It makes everybody happy. So solving it, take the cube root of each side. So that would make x minus 2 equals 0. The cube root of 0 is just 0. So it's 2. If x was 2, 2 minus 2 is 0. So that's what makes the denominator 0, x equals 2. So let's go ahead and draw a line here for x equal 2. So it's on the x-axis through the number 2. So there's x equals 2. Okay, let's talk about the horizontal asymptote on it now. So the horizontal asymptote is whatever you have on the top in terms of x, the highest power, and there isn't one, so we're just going to go with the number on the top, which was 3. So it's y equals 3 over the highest power on the bottom, and that's going to be the x to the 3rd. So it's bottom heavy, so that makes it y equals 0. So it goes right over the x-axis. You almost need a color to make it work well. So you got y equals 0. All right, so taking a look at that on our calculator. So I've got an old one today. I got a whole pile of calculators, so this isn't as pretty as I usually use, but that's okay. So we got 3 divided by parentheses x minus 2 to the 3rd, and then graph. And so since it's such an old calculator, I get that line going down through it, which is annoying. If you have a newer calculator, you're not going to have that line there. But notice here, it doesn't ever cross the x-axis at all. It gets close to it, so we don't have any x-intercepts. But right here we have a y-intercept. And let's cheat and go to the table to get it. Second table, at 0, it is negative 0.375. So let's hit that kind of. We're supposed to label the intercept. So we have 0, negative 0.375. So there it is right there. So it gets closer and closer, and we might as well just look at the table here near that number 2. Well, at 1 it's negative 3, and at 3 it's positive 3. At 1 it was negative 3, and at 3 it's positive 3. Okay, so we can hit those points to kind of make it look prettier. And then connecting it up here, again it gets closer and closer to the y line, and it gets closer and closer to 0, to y equals 0. All right, there you go. So just it's the domain on it's infinite to the left and the right. It's all x's except for x equal to 2, because there's a hole right here. There's that asymptote. So the domain are all real numbers except x equal to 2, or you could write it with a union sign, negative infinity to 2, union of, then 2 to infinity. or you could say it's discontinuous at x equals 2 because you got this gap here. You got to pick your pencil up to draw the other part. So you can draw all that, and you got to pick your pencil up to draw that. So it's discontinuous right there. All right. Next one. It says x squared minus 4x over x squared minus 4. So the best idea to do on these is always to factor it first. Again, it says x squared minus 4x over x squared minus 4. So you can factor an x down to the top, and on the bottom, that factors into x minus 2 times x plus 2. All right, so again, the denominator here tells you where your vertical asymptotes are. So where does that equal 0 at? Vertical asymptotes. So that would be at 2 and negative 2. So x equal to 2 and x equal to negative 2 are vertical asymptotes on it. So let's go ahead and draw those lines. So we got x equals negative 2 and x equals positive 2. And then let's do the horizontal asymptote. Remember, the horizontal asymptote is about the highest power on the top over the highest power on the bottom, and take the coefficients with it. So we got 1x squared and 1x squared. So it's 1x squared over 1x squared. Simplify it, you got 1. So the horizontal asymptote is y equals 1. All right, let's take a look at it here. So y equals, we have parentheses x squared minus 4x divided by x squared minus 4. Oh, that line's driving me crazy. Again, it's an old calculator, so it makes those lines there. You got the newer ones, it doesn't do that. But all right, so it doesn't, well, look over here. It's got a X-Intercept, and it's crossing at 0, 0. You might be thinking, now, wait a minute. It's got this horizontal asymptote. Well, the horizontal asymptote is about the graph as it approaches infinity. So as the graph approaches infinity, it's approaching the number 1. All right, so let's go to the table here. At negative 1, it's negative 1.6. And at positive 1, it's 1. All right, so we can hit those 2 points for fun. But we got to hit the point 0, 0. There we go. And then we want to know what that point is. That's going to be positive 4, because on the top here, the whatever makes this 0 is going to be the X-intercepts. We can talk about that more in a second, but it's 4. 1, 2, 3, 4. It's going through that. And again, it gets close to it, but it doesn't cross it. I mean, it gets close to the 1 and doesn't cross it. And then up here, oh, we might as well go get a number over there. We got negative 3, 4.2. We'll put that on there. Negative 3, 4.2. Let's see, 1, 2, 3, 4. There we go. That'll make it look nice. All right, beautiful. All right, so I was talking about the X-intercept, and how do we get that? The X-intercept is when y is equal to 0. So when y is equal to 0, or f of x, when is 0 equal to x squared minus 4x over x squared minus 4? When is this fraction equal to 0? That fraction is equal to 0 when the top is equal to 0, when x squared minus 4x equals 0. We don't want to know about when the denominator is equal to 0. When the denominator is equal to 0, it's undefined, which is where the asymptotes came in. We want to know when the top is equal to 0. And the top was equal to 0 at 0 and at 4. So that's why you have the x-intercept here at 0 and the other one over here at 4. So again, when you graph it and you graph it well, you hit the intercepts, you hit any max and mins, you put the vertical and the horizontal asymptotes on it, and it looks good. You'll get all your points for that one. All right, on 22, we have the equation x squared plus 2x plus 1 over 2x squared minus x minus 3. Now hopefully you remember the first step here. The first step is to go ahead and factor it on the top and the bottom. So the top factors in the x plus 1 times x plus 1, and then the denominator factors into 2x minus 3 times x plus 1. So this is kind of fun. I don't know if you see it, but on the top and the bottom, they both have an x plus 1. So you can cancel it out, and that makes a whole. So the first thing we were doing before, and it's still the first thing we're doing, is we're looking at what makes the denominator equal to 0. So you set this equal to 0, and you get x equals 3 over 2. And it didn't cancel out, so it's a vertical asymptote. This also, we got x equals negative 1, but it can cancel out on the top, so that makes it a whole. And so it's fun to find where exactly is the whole at, and so to find where a whole is at, what you do is you plug that number back in. You plug negative 1 back into f, but you plug it into the equation after you get rid of the whole. So after we cancel out the x plus 1, we're left with an x plus 1 over 2x minus 3. Plug the negative 1 in, and negative 1 plus 1, 0. So it doesn't matter what you get on the bottom, but it's negative 5. So the whole is at negative 1, 0. So at negative 1, 0, I'm going to put a whole. And then we have that vertical asymptote at positive 1.5. So I'm going to go ahead and draw that. So that's x equals 1.5, or 3 over 2. All right, that was a lot of fun. We still got to do the horizontal asymptote. So that was all about the denominator and where the denominator is equal to 0 at. And the denominator will, again, make either vertical asymptotes or wholes. Okay, so then y, the horizontal asymptote, looking for that now. Y is equal to the power on the top, the highest power, which is x squared, over the highest degree on the bottom, 2x squared. Oh, look at that. We can cancel out the x's, and we end up with 1/2 then. So we have the horizontal asymptote of y equals 1/2. Kind of fun. All right, let's put it in this old calculator. So we got x squared plus 2x plus 1 divided by 2x squared minus x minus 3. All right, graph. There it is. Okay, someone will say, well, wait a minute, it graphed the whole. Well, yeah, it kind of graphed the whole, but not really. If you go to the calculator to the number -1 on the table, second table, -1, it says error because it's not there. And then you're not going to find the other asymptote because it was at 1.5, so it's not going to show it on the calculator. But yeah, there's a hole there. And then it looks like it's going through, well, let's go to the table. It's not quite going through that. It's going through 1/3. So at 0, it's going through -1/3. If you plug 0 in for x, you get -1/3. So let's make sure we hit that. So that is the y-intercept, 0, -1/3. And again, you can get that one by plugging in x equal to 0, and that gives you the y-intercept. So if we put a 0 in back here to the original equation, all the x's are gone. You're left with 1 over -3, so -1/3. That's where that comes from. All right. And so it goes through that. Honestly, I don't think we really need much more than that. And it gets close to the line 1.5 there, and it gets close over here to the 1/2. And then we'll go ahead and get that corner point there. Let's see where that's at. So that gives us over there 1, -2, and 2, 3. 1, -2. Oh, that was on the other one, I think. It was. 1, -2. All right, let's go to the other side of it. At 4, we have 1. 1, 2, 3, 4, 1. All right, it just gets small then. And at 2, we have 3. 1, 2, 1, 2, 3. There we go. All right, that'll work. All right. Beautiful. We have the intercepts. We have the asymptotes. Looks good. All right, and I think that's about it. We're about out of our time for a YouTube video. All right, I'll see you later.